It is a lovely day. Welcome to Chemistry Me. I'm glad to have you once again on this platform. Today on Chemistry Me, we'll be considering JAMB 400 series. And in this series, we answer a lot of questions from UTME, that's Unified Tertiary Matriculation Examination. We know that the exam is fast approaching now. We are trying everything possible to make sure that we prepare students properly for this exam. You can still join our WhatsApp group because currently we are running an intensive revision series on our WhatsApp group in order to prepare students for this exam. So in this particular episode, we'll be looking at a chemistry question from 2007 UTME, and this question is from organic chemistry. All right, let's quickly deal with the question. How many structural isomers of chlorobutane are possible? Now we know that in chemistry, in organic chemistry precisely, we have what we call isomerism. We said that isomerism is a phenomenon where two or more compounds have the same molecular formula but different structural formula. We know in organic chemistry we talk about empirical formula, molecular formula, we also talk about structural formula. So when you have two compounds having the same molecular formula but different structural formula, then those compounds are said to be isomers, and that phenomenon is what we call isomerism. So if, for example, I have butane is C3 to CH2 to CH2 to CH3. That is C4H10. That's butane. So this is the straight chain butane. Then we can have a branch chain which we call 2-methyl-propane. Now if you check the total carbon here, 1, 2, 3, 4 is 4, and hydrogen 3 plus 3 plus 3, 9 plus 1, 10. So you see by molecular formula, the molecular formula of this is C4H10. Now when you look at this also, the molecular formula is also C4H10. But if you look at their structures, they are not the same. So they are what? They are isomers. They are isomers. So we want to answer this question on isomerism. Now, if you must actually answer questions on isomerism, you must know how to draw structural formula of Of organic compounds. So let's look at this question. We're asked to find the number of structural isomers that are possible in chlorobutane. Now, chlorobutane is actually by molecular formula C4H9 then Cl, because butane is actually C4H10. Now we know that butane is an alkane, and alkanes are saturated. They are saturated, yes. Alkanes are saturated because we have single bond between the carbon atoms. Now, because they are saturated, they can only undergo substitution reaction. So when you add chlorine to butane, you are going to form chlorobutane because one of the hydrogen atoms in here will be substituted with a chlorine atom. All right, so that's how chlorobutane was formed. Now, if we begin to draw the structure of chlorobutane to get the isomers, the first one will be this: CH3 to CH2 to CH2 to CH2, then to the chloro group. Now, this is the first, that's the straight chain. This is actually 1, 2, 3, 4. So this halo group, that's the chloro group, is on the first carbon. So 1, 2, 3, 4. So this is actually 1 chlorobutane. 1 chlorobutane. We'll still remember the rule in the nomenclature of organic compounds. This is a haloalkane. A haloalkane is an alkane that contains a halogen atom. So when we substitute hydrogen in an alkane, we form alkane. So this is a haloalkane. So this is 1 chlorobutane because the chloro group is on the first carbon. So when you number from here, 1, 2, 3, 4. So this chloro group is on this first carbon. That's why it's 1 chlorobutane. Now we can actually change the position of this and attach it to any of the carbons in between, because if we take this to this place, we'll still have one chlorobutane because we'll now name from here. So we cannot attach this again to a carbon at the what end, because if we attach it, we just return to this. Okay, so I can decide to fix this, the chloro group here, and then I have this. So when I fix the chloro group here, you remember in organic chemistry, carbon must have 4 bonds. So if I fix this here, it will increase the number of bonds in carbon, making it 5. Why this number of bonds in carbon will reduce? So we do a hydrogen balance. That's why the moment I attach this chloro group here, then I have to take out 1 hydrogen to balance the hydrogen that's supposed to be on this carbon. Now, if you look at this 1, 2, 3, 4. 1, 2, 3, 4. So this is another isomer of what? Of chlorobutane. In this case now, the chloro group is on position 2. If we count from here 1, 2, 3, 4, it will be on position 3. But we know in nomenclature we usually usually use the lower what? Position of the substituent group. So we will not have 3 chloro, but rather what? 2 chloro. So we number from here 1, 2, 3, 4. So this will become what? 2 chlorobutane. Now if we shift this here, it will still be 2 chloro what? 2 chlorobutane, because that means this end is now closest to the what? To the functional group. So we'll number from here. So shifting this here will not make it 3 chloro, or rather it will still be 2 chloro. Okay. So that means it's still possible for me to move an alkyl group. That means I can reduce the chain to 3 what? To 3 carbon. Or before then, I can, okay, let's reduce the chain to 3 what? To 3 carbon first. Let's reduce it to 3 carbon. So this is the first isomer, second isomer. If I reduce this to 3 carbon, to get my third isomer now, CH3 to C, to CH3, to CH3, to Cl. Okay? Alright, let's look at this. Now if you look at this now, 1, 2, 3. So this chloro group is at position 2. That means we have an alkyl group also. So if we want to name this now, if you check, the number of carbon here is still 4. 1, 2, 3, 4. And hydrogen is still 3, 3, 3, making it 9. And then we still have chlorine. So the structure, the molecular formula is still what? The same. So what is now the name of this? We have 2 substituents now. This serving as a substituent, that's the functional group, and this also is substituent. And when we have different substituent group, we arrange them in alphabetical order. So we are going to, C comes before M, because this is methyl. So we are going to have 2 chloro, then 2 methyl, then what? Butane. Sorry, in this case now is propane, because the longest chain now is 3. So we have 2 chloro, 2 methyl what? Propane. Then one more. I can still pick one more out. Remember the structure, the molecular formula of chlorobutane is this. So what if I move this to position 1? So I will now have the 4th isomer to be CH3, to CH, to CH3, to CH2, to Cl. Okay? I will now have this. So in this case now, the chloro group is on position 1. We will not number from here because we number from the carbon closest to this functional group, because the functional group in this particular organic compound is this chloro group. So if we number, it's going to be 1 here, 2 here, and 3. So the chloro is on position 1, the methyl is on position 2. So we have 1 chloro, 2 methyl, 2 methyl propane. Because it's 1, 2, 3, or 1, 2, 3, 2 methyl propane. So how many isomers are possible? Structural isomers are possible in chlorobutane. It is actually 4 structural isomers. For more, on organic chemistry, you can actually contact us so that we can put you through, especially if you are having problems in the nomenclature of organic compound. We shall be back and we'll still look at another question, possibly still on organic chemistry. Thank you for watching. Remember, there is need for you to subscribe to our YouTube channel and follow us on Facebook. Thank you and God bless you. I love you.